2.2, limits involving infinity.
Are these long notes?
No. All right. Consider f of x is equal to 1 over x. As x approaches infinity, 1 over x goes to 0. Okay, because it's some really big number on the bottom. So like 1 over 500. That's getting close to 0. So the limit as x approaches infinity of 1 over x is equal to 0. And as x approaches negative infinity of 1 over x, as x approaches negative infinity, 1 over x approaches 0. So the limit as x approaches negative infinity of 1 over x is equal to 0. Then the line, or here, this is the definition of a horizontal asymptote. The line y equals b is a horizontal asymptote of the graph of a function y equals f of x if either the limit as x approaches infinity of f of x is equal to b, or the limit as x approaches negative infinity of f of x is equal to b. So we're going to go back and look at the sandwich theorem briefly. So if we have the limit as x approaches infinity of f of x for f of x being equal to the sine of x over x. The sandwich theorem, I can't spell, would say that we have negative 1 over x is less than or equal to the sine of x over x is less than or equal to 1 over x. So, by the sandwich theorem, 0 is equal to the limit as x approaches infinity of negative 1 over x, which is equal to the limit as x approaches infinity of the sine of x over x is equal to the limit as x approaches infinity of 1 over x, which is equal to 0. So since sine of x over x is an even function of x, we can conclude that the limit as x approaches infinity of the sine of x over x is equal to 0. Sandwich theorem basically just allows us to say if we know the two things on the outside, we can figure out what's on the middle, in short. When we actually do like some problems with it, it'll make a little bit more sense than what it probably is doing right now. And if you try to understand it right now, it probably still won't make sense. It's one of those you just have to see it a few times, to be completely honest. The properties of limits all still hold for limits at infinity. So they're written in your book again, specifically for the limit at plus or minus infinity, but it's the exact same ones we wrote down the other day, so I don't really feel like we need to probably write them down again. So if you want, it's on page 71 if you just want to reference them specifically, but they're literally all the same. So, the definition for a vertical asymptote so the line x equals a is a vertical asymptote of the graph of a function y equals f of x if either the limit as x approaches a from the right of f of x is equal to plus or minus infinity, or the limit as x approaches a from the left of f of x is equal to plus or minus infinity. All right, and then the last thing we've seen before, we saw it for the first time in Algebra 2, saw it briefly in Pre-Cal, and I'll say a little more depth than we saw it in Algebra 2, and now we're going to get to see it a lot more, is the definition for the in-behavior model It was basically what happens as x gets really, really big or really, really small. So as x got really far this way or really far this way, what happened?
How many lines will we need for this? I have 4 lines left.
It depends on if you can write a limit of a fraction on one line or not. It's this much, but you might be able to squish it in there. And you might want to write what I'm about to write beside here if you don't have that much space. The function g is, so the first one is going to be a right end behavior model for f if and only if the limit as x approaches infinity of f of x over g of x is equal to 1. And B, a left-in behavior model for f if and only if the limit as x approaches negative infinity of f of x over g of x is equal to 1. So typically we only look at whatever the highest powered term is when we're doing this. That's what will tell us what's happening. The rest of it is going to be irrelevant when we're going out to infinity, basically. Alright, so that's it for today.